So we're now looking at travelling salesman. So we are told that the minimum time is X minutes, so we need to use X in our equations. So starting from TR, nearest neighbour, to find an upper bound. So key things with the nearest neighbour, you always go to the closest one. You can't go to a place that you've already been, and you have to go back at the end. So for TR, the closest thing to TR is 26 going to MT. So we've been there, we've been there. Closest thing here is going to be AG at 28 because we've just come from TR. So 28 to AG. Closest thing to here, can't use the 28, we've just come from there. Can't use TR because we went there first. So we're looking at going 56 to CA. CA's got 14 to PE. PE, we've only got LM to go left, so that will be 33 to LM. We've now been everywhere, so we go home at the end of our tour. LM to TR is 42. So our upper bound for this, we're going to need to add these together, and that gives us 201. So our upper bound, we have X has got to be less than or equal to 201. Okay, part B, tour starting from Cardiff. CA is Cardiff, so if we are starting from Cardiff, we then went to PE, we then went to LM, we then went to TR, and from TR we went to MT, to AG, and then back to Cardiff. There's a reason it's a 1 mark question. It is basically copy what you've just done, starting in a different place. Okay, so next, by deleting Abergavenny. So if we start off by deleting Abergavenny, we need to now find a lower bound for X. So if we are doing a lower bound, we need to do prims on tables on the bits that's left and add in the 2 shortest from our deleted. So the 2 shortest from our deleted are 28 and 54. So if we stick that just down here, we've got AG, which goes to MT, and that is 28, and we have AG goes to TR, and that is 54. So that's the bit that turns it from a minimum spanning tree on the other bit into a lower bound. So from here, we're doing prims on tables. So it's always easiest to start at the first one. So if we highlight the column and cross out the row, we are looking for the smallest thing in our highlighted column. This is the first thing that we've got. So we've got CA going into our network. This is the smallest thing we have. So for our list, we go CA, P, E, and that is 14. on our network, we've now got CA added into PE. PE is the second one that we have chosen, which means we have to highlight PE and cross out PE. We're now looking for the smallest thing highlighted, which I think is that 33. So we've got PE to LM is 33. We can stick LM on our network. LM is the third one we've added to our network. So we can highlight it and cross it out. So smallest thing highlighted, iMake is 39, which is back here. So we are adding MT onto our network. We are adding CA NT onto our list at 39. It's the fourth one we added to our network. So we highlight it and we cross it out. So we're now looking for the smallest thing highlighted, which is this 26. So that 26 adds on TR on from MT. So MT to TR is 26. That it will be the fifth one chosen, the fifth one added. So from here we need to add them up. So we'll have a total which is 112. So our lower bound is worked out from this minimum spanning tree and these two others. So our minimum spanning tree, our lower bound, sorry, is going to be 112 plus 28 plus 54. You do need to show them this bit of adding, and that is 194. It is a lower bound, so that tells us that that is going to be less than or equal to x. So, using the answers to part A and C, what do you know? You've got an upper bound in A, you've got a lower bound in C, so the smallest interval it can lie is between your upper bound and your lower bound.